Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will discuss a very important theorem. Every subgroup of a cyclic group is cyclic in group theory. Every subgroup of a cyclic group is also cyclic. Means that the cyclic all the subgroups of cyclic group are also cyclic. Let's come to the proof. Let let G be a cyclic group generated by A. Means that all the elements of G or the powers of A are can be generated by A. Let H be the subgroup of G. It means that all the elements of H also can be generated by A. And K be the least positive integer. K be the least positive integer, the smallest integer, such that A raised to power K belongs to H. A raised to power K belongs to H. We have to prove that H is generated by A raised to power K. As A is the generator of G, similarly A raised to power K is the generator of H. As in a group we discussed in our earlier lectures that G is equal to 1 minus 1 iota and minus iota. It is generated by iota. And its subgroup H is 1 and minus 1. It is also a cyclic. This group is also cyclic. This group is also cyclic. And it is a subgroup of G. And we know that it is generated by iota and it is generated by iota raised to power 2. This group is generated by iota raised to power 2. How? When we take its power 1, it gives us minus 1. And when we take its power 2, iota square into 2, it gives us iota raised power 4, which is 1. From here you can easily understand that this A raised to power K means iota square, and this A means this iota, which is generator of G. Iota is generator of G and iota square is generator of H. For this, let A raised to power M belongs to H. If we take the power of A as M, as I said that A is the generator of all the elements of G and A is also the generator of all the elements of H. So every power of A gives us the element which may belong to G or H. So here for all M is greater than K, because K is the smallest, we take as the least positive integer. So there exists Q and R. Q and R we introduce for division algorithm. When we compare two numbers, one is greater and one is smaller, then we may do comparison of them by doing division algorithm. So here we check either K divides M or not. Either remainder R comes or not. Here we see that M is equal to K. For example, let me say that M is 5 and let me say that K is 2. When we divide when we divide 5 by 2, 2 2s are 4 and 1. Here 5 is M, 2 is K, this 2 and this 2 is Q and this 1 is R. I hope you understand the division algorithm. Let's take equation in the power of A. Here this side will be the power of a raised to power m and a raised to power k cube plus r, and as we can write also ak into raised power into a raised to power r. So we can also write it a raised to power k into raised to power q. As q comes the second side of equation, then its power become negative because it is the inverse of that. Here its inverse come. So we find the equation a raised to power m dot a raised to power k. A raised to power k is the generator of h is equal to a raised to power r. What we conclude here? We conclude here that a raised to power m and a raised to power k raised to power q are in h as we described earlier. Therefore, a raised to power h also, a raised to power r belongs to h also. But since we said that k is the smallest integer, very small integer k, a raised to power k belongs to h, and r is less than k because it is a remainder, so it should be smaller than the divisor. So k is the divisor. So a raised to power k belongs to h is possible if and only if r is equal to 0. If the remainder is equal to 0, because k is the very small integer we have taken. So again we can write m is equal to qk. Taking again powers of a raised to power m is equal to a raised to power kq. So a raised to power m is equal to, we can write it also a raised to power k into q belongs to h, because we know that a raised to power k is the generator of h. So here we proved that a is the generator of raised to power a raised to power k is the generator of h. Hence proved that h is a cyclic because h is also generated by a single element. Here the proofs ends. Thank you so much.